So if you're seeing my screen, you see problem A on
Yes.
the worksheet here. Okay, so the law of sines. I'll do an LOS for law of sines. Um, it requires an angle side pair.
Okay.
So see how there's an angle and a side pair.
Yeah, I see that.
Okay. So there's a version here where you either solve for the angle or the side. In this case, we're trying to find the angle. So you put the missing angle in the top, sine of x over the side, 22, equals sine 42, because that's the angle you know, over the side across from it. And then you solve for x. So you solve for x by clearing this 22. So sine of x equals 22 over 17 sine of 42. And then you have to undo sine with the sine inverse. So you just do a sine inverse 22 over 17
Oh,
like
okay.
that. And that'll get you the value of x, which I guess is all that they want you to find in this one.
Yeah,
Yeah.
these are pretty straightforward.
Um, and that actually is in the answer is there. It's about 60 when you do it. So okay, so let's do B. Do B.
Yes.
Run through these as quickly as I can. All right. So B. Uh, this time, we're trying to find, well, trying to find x, which is a side, so we need the angle across from it, but we're
Mhm.
not given that angle because the angle is unknown, but we can find the angle. This angle here is 180 minus 35 minus 88. Okay,
That's good.
so we can get that value. I don't know what that is, but I grab a calculator here and pull that up and I get the value. So 180 minus 35 minus 88, we need that value. That's 57 degrees. Okay,
Yes.
so we're trying to find x over sine 57. So notice in the previous problem we put the sine up top and the side on the bottom. You can do it either way. I always put the unknown though in the top left, and then we need another angle side pair. So we've got that the side is 44 over this, and then the sine of 88 here. So x equals, we got to clear this sine 57. So we're going to multiply both sides by sine 57. 44 sine 57 over sine 88. Should have mentioned this in the previous problem. If you're going to if you're going to use your calculator, make sure it's in the mode is in degrees.
Degrees. Yeah.
Took me a while to say that. Okay, and so that's gets, it looks like it's 36.9 and then millimeters, because the side is in millimeters, so the other side must also be in millimeters.
Mhm.
So you can use law of sines to solve for either a side or an angle. It can be used for both. The two types of questions you might see. So again here, this angle is across from this side. This angle here, x, is across from the 6. So we have everything we need. When it's inside here, we say the sine of x. So we're putting the angle up top, the side on the bottom, equals sine 51 over 9.4.
Multiply across, and then it's oh wait.
Yeah, so you have to clear the 6 from the bottom. So it's 6 over 9.4 times sine of 51. And then that last step is you have to undo sine with sine inverse. So it's sine inverse of 6 over 9.4 sine 51. Now, I don't think we've yet had an exception to this.
This. Mhm.
I don't think there are any, but sometimes you get an error here, and that's because the angle doesn't exist. I'm not seeing that, but that is something to look out for. Not seeing it in this worksheet, but that's something to look out for.
All right.
All right, letter D, angle question D.
Yes.
Okay, so again, we got this angle, this side across from it, this side, this angle across from it. So we're looking for x, sine of x over 13 equals sine 67 over 12. Um, the
13 sine x, sine 67 over 12, and the
yes,
sine inverse. All right.
So at some point you get to where you're like, okay, I can just do all these steps in one shot, which is preferred, and then you get the answer here, which 85.7. So it really isn't that much work, but there's a lot that goes into knowing the work. So let me snip here. Why I can't? Oh, I guess every time I snip, my screen goes gray. It's interesting. Okay, we got angle and the side across from it. We um, we have a side. We don't have this angle right here. So to get this angle, we have to take 180 and subtract 48 and subtract 61 from it. Actually, it's been a while since I've seen this variation on the problem, but that's a good one. So that's 71 degrees. So now we've got the missing angle side pair. So when we're looking for the side, you put the side up top, sine of the angle across from it on the bottom, sine of 61 equals 21 over sine 71. Okay, so you got to clear this out. X equals 21 sine 61 over sine 71. And that equals whatever it equals, 19.4. And that's centimeters.
All right. On the next one.
Yep. Get that last one, I think. Yeah, okay. They actually, 2 actually redoes the lettering. That's interesting. Okay. So here's the side. We need the angle across from it. And that's 180 minus 118 minus 52. That ends up being 10 degrees. So since x is the side we're trying to find, it's sine of the angle across from it. That's 10 degrees there. Sine of 10 equals 45, because it's a side, the tops are sides this time, over the sine of 52. So that means that x equals 45 sine 10 over sine 52. And just full disclosure, I'm just grabbing the answer off of the answer key rather than
It's okay.
out. But that's
No worries.
that's what you should expect to see, and that's in meters.
Awesome.
Okay, we'll go on to 2A. So 2A is just more. It's just more of the same. You got to solve. You got to solve the whole triangle now. So you've probably heard this, like, low hanging fruit. You want to do the easy stuff first. The easiest thing here is this angle. Whenever you're given 2 of the 3 angles, you want to find the other angle.
180 minus whatever that is, which is like
Yeah.
121. And then it's 59. Yeah, 59.
58.
58. Okay.
Yeah, 58 degrees.
Oh
Okay.
yeah, because 2 plus 2. My bad.
So now we got to find little c and little b. It's little c because it's across from big C. So we're going to find c, little c first. So little c over sine 58 equals, then you need a side angle pair. So that's 9.8 over sine 71, because the angle side pair are across from each other. So c equals 9.8 sine 58 over sine 71. And that is not given. Wow. They don't have that in the solution. All right, so we'll do it by old-fashioned way, with the computer. All right, 8.8. Okay, and then to find b, it's the same. It's the same way. It's b over sine of the angle across from it, 51 degrees. And then you can use either side angle pair, but I always try to use the given information in case I've made a mistake, because that way it's using given information rather than the calculated values. So let's see what we got here. Oops, didn't like that. Okay, 8.1. 8.1 centimeters. For some reason, your solution did not come with those values. So, all right, on to B.
Mhm.
On to B. All right. So again here, what's the missing angle?
Missing angle here. Right, so 84 plus 42, 126. So that's 54.
Checking the solution. It is 54. Yep, 54 degrees. Okay. So this is little j and this is little l. We're gonna find little j first because you can find either one, but I'm gonna just choose to find little j first. So j over sine 42 equals, and then you want to use the angle side that you have. So 50 over sine 84. So j is equal to 50 sine 42 over sine 84. And according to the solutions, it's 33.6 for that.
All right. And now we're looking for L.
Yes, so L is solved the same way. So L is, L is over the sine of this angle, 54 degrees. That's why we found it, equals 50 over sine 84. L equals 50 times sine 84. 54. Sorry, my handwriting's getting bad here. 54 over sine 84. And then that equals, where is it? 40.7.
What? I didn't want to cough on everybody while I was swimming.
Jack, let me know when you're back with me.
Yeah, I'm with you. Okay, let's get moving. Or do you want to move on to the next one?
Yes, absolutely. The next one here is C. These are a little slower because I have to do a few more calculations for them. So the first couple, they gave you two angles and a side. Now they give you two sides and an angle. That means you're going to find the angle first. So to do that, you put we're going to call, so we're finding the sine of big R, and it's across from the 15. And that equals, well, you have the 98, sine 98 over 17.5. Okay. So R, this is the shortcut, is sine inverse of 15 over 17.5 sine 98. And that value is not given. Oh my gosh! Wait. Maybe I'm not looking at the right thing. Probably not looking at the right thing. It is given. It's 58.1. All right.
And now we.
So to find S is this is where it's a little different. It's 180 minus R, which you just found, minus the other angle.
Huh.
So you only have to do law of sines once to find the angle. Like after that,
Let's find the side, right?
yeah. So now to find the other side, this is where you got to use law of sines again, but we're trying to find little s. So little s over sine of the angle of s, which is 23.9 equals, You can use another side pair, but I recommend using the given information. So 17.5 over sine of 98.
All right, so now we're gonna have
So S is equal to 17.5 sine 23.9 over sine 98.
that's the whole. All right, let's see. And that's gonna be, what is it? 7.16 meters.
So that, yeah, let me just confirm that. Yeah, it's 7.2. And that closes that one out. Yay. These are so long. All right. So I'm gonna, Jack, because I want to help you.
You want to move on to the other ones?
Yeah, I want to
I'm
make
fine
sure
with that.
okay. I
Let's go
may
on to 9.3.
I may regret that here in 30 seconds when I see what it is, but that is what it is.
Mm-hmm.
All right. Express each as a single trigonometric function. Okay. All right. Yeah. So these are all going to be from that trig cheat sheet that I probably had you look at a billion times, or every not that many, but okay. So this is the first question I'm seeing here in 9.3. So let me pull up the Lamar cheat sheet. If you want, I can send you the link to it, but I'm just going to snip in the ones that are relevant for us today. So here is the first one that we need. So when you look at the one that I've just snipped in here, on the right side, do you notice how the right side looks a lot like what you have? It's like basically the same. Well, your theta is 2 pi over 3 in your problem. If you've been talking, you're muted, so I can't hear you. But theta is 2 pi over 3, and they want this to simplify, so it's tangent of 2 times 2 pi over 3.
Okay. Wait, so what do we do now?
Well, the answer, I mean, your final answer is tangent of 4 pi over 3.
Oh, that's it? Oh, okay.
Yeah,
That's the whole answer for that? Or do we have more to it?
that's it. No, that's it for that one.
Okay.
But it comes from the double angle formula for tangent.
Okay. I guess let's move on to the next one.
All right, the next one is it is also a double angle formula, so I will snip that in. There's not a ton of work for these, so you may find that you actually can just write down the answers for these pretty from the solution sheet. Let me snip in the double angle formula for this one. So this is the sine double angle formula, and because
Okay. So we got. So what are we plugging in for? Wait, so
you're trying to match what you have. You're trying to match this to this, and what is the thing that's the same?
uh,
I'm giving you. I'm
there's
really
sine and cosine, but
well. I'm telling you that theta is 87.
so theta is 87 for both. Okay.
Yeah, so that means that this right here is sine of 2 times 87, which is the sine of 174 degrees.
Oh. That's just the whole problem right there, right?
Say that one more time.
That's just the whole problem, right?
That's it. Yeah, that's it. And that's what I mean by you can sort of write down the answers because they're all these sort of one steppers.
Mhm.
3 is one step. Now this one's pretty short, like this worksheet, so we might get through everything. This is a half angle formula. So if you know the half angle, and that's it's a big one. If you know it, then you can you'll see this right away. So so in your problem, theta is pi over 6. Do you see that?
Yes, I do.
So this thing that you're trying to write down, it's sine theta over 2, but your theta is
Uh,
pi over 6 over 2, which is sine of pi over 12.
oh, okay, I see that. So it's just all like this. It's just these one steppers.
That's it.
All right, let's on the
So,
yeah, on the number
so
four.
um, if you want, I'm just gonna say well, we're almost done with this, but you could literally just write down the answers. And there's really not any work. I mean, there kind of is, but kind of isn't. So let me snip in the next formula.
Mm-hmm. 1 plus cosine 8 theta over 2.
Yeah. So this is another half angle formula. This time it's cosine. Your theta, like in your problem, theta is really 8 theta. That's what that
Oh,
means. So you're going to write this cosine theta over 2, but your theta is 8 theta, which equals cosine of 4 theta.
okay.
And that's theta. I sometimes mispronounce it. Don't speak clearly. All right, number 5. We are really moving through this. Okay, that's great. Number 5, 1 minus 2 sine squared theta. So again, like I don't. I mean, I'm here to help you, obviously, but like maybe it's too much help if I'm just telling you
How to do
which
it?
which one it is without making you look. I don't know. I don't know, Jack. It's
More challenging
I
online.
mean, yeah, I'm here to
Yeah.
help. So um, but each one of these is cosine of 2 theta. Just it comes in, I call it, say 3 flavors. You want this one down here because that's what yours looks like. And your theta is 28 because
Okay.
yours looks just like this on the right. So you're going to write cosine of 2 theta, but your theta is 28. So it's 2 times 28, which is cosine of 56.
All right.
Last one. I hope the next worksheet is this short because we will actually get through everything. All right, number 6.
So this is 6 pi. 6. No, theta. Okay.
Yeah, so interestingly, this one doesn't resonate with me at all. I'm gonna look at the answer because I have no idea what they want you to do here. Tangent 3 theta. Well, okay, so I'm sort of dumbfounded here. Really? So it's tangent of 3 theta is the answer. Okay. I
Theta
really,
like 1/2 here or something.
yeah, it's not that simple. Oh, you know what? Maybe, you're right. You are right. It is right. No. Minus cosine 2 theta. Um, yeah, I'm gonna not be able to help on this one because I really don't have a good direction on it. So let's move to 9-4.
All right.
Okay, this one is okay. So, all right, okay, we every one of these problems is in 9-4 is it's a unit circle lookup, and there's no work to be doing. There's no work. There's no steps. There's just this is going to the unit circle and knowing knowing this information. So how do I help you best here? I guess I could guide you through it. All right, so here's what I'd like to do. I'd like to I'm going to snip in rather than I'm going to talk because you've got the worksheet up, I assume, right? You've got this worksheet up, Jack, 9.4.
What'd you
Can't
say?
hear you. Do you have the
Unit circle in front of me? I do not, but we can go through this one that you have in front of me. All right, so it was something like 6 pi, or no, 6 theta. What do we do with that information, though?
which one?
Wait. Are we
I'm
starting
sorry.
on our problem right now?
Yeah, we're looking at you. Do you have worksheet 9.4 up?
I'm pulling that up right now.
Okay.
All right, 9.4 review. Okay. Which problem are we on? Number 1?
Number 1, yeah.
All right.
So all of these are unit circle lookups, and that's why I've got it here so that you can see how quickly we can do
Oh,
this.
negative. Wait, what does that mean by like sine negative, though?
It means for what angle is the sine of that angle square root of 2 over 2?
Side is y, right? Cosine x, sine y.
Yeah, it's basically saying for what angle is the y value square root of 2 over 2?
The y value is pi over 4 or 45 degrees.
Right, pi over 4 or 3 pi over 4.
Yeah.
Okay. Now here's the thing with sine inverse, you're limited to
Those
only
two?
only the first and fourth quadrants. So therefore it must be pi over 4.
Oh. Wait. Oh, okay. I see what you mean. So what do you end up writing on paper, though?
There's nothing to write down. That's what I was trying to emphasize. Is like
Oh, you're
there's
just
literally no
drawing it?
steps. Yeah, it's just a lookup.
Huh. Okay. I guess let's see what number 2 is. So tangent -1 of 0.
Yeah, so it's saying where is
0 for tangent.
so that's saying where is the tangent 0, and the tangent is 0 at 0 and then pi. Okay,
Mhm.
but sine and tangent are good only in the first and fourth quadrants, so it must be 0.
Hmm.
And that's why when you look at the answer, it's 0.
All right.
Okay. So cosine inverse of 1. For what angle is the cosine of that angle 1? Well, it's right here at 0.
All right.
So let's do like number 4. The cosine, where's the cosine? For what angle is the cosine of that angle negative square root of 2 over 2? So that's that's over here at 3 pi over 4 and 5 pi over 4. Okay.
Yeah.
But cosine is only good in the first, cosine inverse is only good in the first and the second quadrant. So therefore it's 3 pi over 4 has to be the answer.
Three pi over 4. Okay. This one is 2. All right, let's go on to the next one. Wait, am I talking? Yeah, I'm talking. Okay.
Okay, so the next one, is sine inverse of 1. So again, like where is the sine 1? Well, it's 1 at pi over 2, and that's the only place, so that's your answer.
Can you say that one more time? So it's at like pi over 2, is that what you said?
Yeah, just pi over 2. I mean, the second page has all the answers, so we're just...
Oh, okay. I see what you mean. All right, so which number are we on now?
Number 6.
Number 6. All right, so cosine of -1, go to...
So where is the x value -1/2? And there it's at 2 pi over 3, and down here at 4 pi over 3. But cosine is only good in the first and the second quadrant, so it must be 2 pi over 3.
All right, so can you write down which quadrants it's only good for? So it's only good for quadrants 1 and 2, is that what you said?
Yeah.
Okay, so that's when it's only good. Okay. So let's make on to number 7, and number 7 is -3/2, not -3/2, but 3 rad 3 over 2, and 3 over 2 is at, what is it? 3 over 2, 3 over 2, -3 over 2, at 150 degrees, and at... Wait, am I just doing the same one again?
Which one?
For number 7? Because it looks... Or are we on number 8 right now?
We're on number 7, and
Okay.
it's
Because it was at the same places. All right, so it looks like it's just going to be that that negative pi over 3.
okay. Um,
You want to go back to 10.1?
I would, because this is we can do more of these, but they're all the same. They're all just figuring out there's always 2 places in the unit circle, and then you pick the one that works in the quadrants that we're given. So yeah, so let's go back to 10.1, and we'll finish this off.
Yes.
And we'll probably have some extra time, so we'll be able to come back to this.
Mhm.
Okay, so we left off at D, 2D, and I will snip that in. All right, so the angle that's missing, we can find right away. Y is 180 minus 22 minus 39. And that value is
Minus 89. Okay.
119. 119 degrees.
Yeah.
All right, so now we have a choice. We can find either side X or side Z. It doesn't matter. It's up to you. We'll just find X first. So X over sine of 22 equals, we're trying to find, we need another angle side pair. So we've got 29, that's the other side, over the sine of 119. So X is equal to 29 sine 22 over sine 119. And that is 12.4. Z over sine 39, that's the angle that's across from it, equals, and I'll just use the same values up here, 29 over sine of 119. So therefore Z equals 29 sine 39 over sine 119.
All right. onto say so Z
Ends up being, according to the solution here,
20.9.
20.29. Yeah.
Awesome. We found the angle, so we're done with D. All right, let's go on to E.
All right, letter E. 2E. All right, so this time you don't have two angles, so you can't find that third angle. You've got this angle and this side, so we've got to find angle I first. Sine of I over 8 equals sine of 115 over 13. So when you solve for sine of I, you just clear out the 8, so that's 8 over 13 sine 115. And then I equals sine inverse of 8 over 13 sine of 115. And that is 33.9 degrees. So now once you have one of the angles, you can find angle H by subtracting the other two from 180. 115 minus 33.9. So it ends up being 31.1.
No, we're looking for the other side now.
Little h, yeah. So to find little h, oops, I cleared it out here. Little h over sine of big H, sine of 31.1 equals 13 over sine of 115. So then solving for h, you just clear out the sine 31.1. 13 sine 31.1 over sine 115 equals so 7.4 centimeters.
That's it for that.
That's it for that. One more though. We got letter F. All right. So again, you don't have two angles, so you got to use this angle side pair, and you're forced to find O because you have this side, but you don't have that angle. Sine big O over 28 equals sine 62 over 31. So sine O equals 28 over 31 sine 62. So O is equal to the sine inverse of 28 over 31 sine 62. And that ends up being, according to the solution sheet here, 52.9 degrees. Okay, so to find angle M, you're going to subtract from 180 the other angles that you have.
You get, what is it?
And you end up getting, let me find that here, 65.1 degrees. So now we have to find side little m. You put m in the numerator, this is law of sines, over the sine of big M, which is 65.1 equals, and then you use an angle side pair of the chart I have, so I'll use this 31 over sine 62. So m is equal to 31 sine 65.1 over sine 62. And that ends up being 31.8.
So now we got all the angles now. Now we're looking for the last side, and then
All sides are
31.8.
Yeah.
All right.
Okay, so let's spend some time. Let's go back to 9.4, and I'll try to do this better. Sorry, these are there's a problem before this that's easier. Do you have a unit circle that you can?
I'll pull it up right now. I actually have the
Okay.
cheat sheet that you gave me from a while ago. All right, so
Okay.
let's see.
That'll be very helpful because that'll make this go faster. So,
All right,
um,
so I got one in front of me. All right, let's go.
all right. So the sine inverse of -1, again,
Mhm.
it's saying where for what angle is the sine -1? Well, the y value there is at 3 pi, 3
Over
pi over
over
2.
two.
Okay, but sine inverse is only good from, oops, I drew the wrong picture. It's
Section
only
1 and 2.
minus pi over 2 to pi over 2.
Mhm.
So 3 pi over 2 is the wrong way. So this you have to convert to an angle in here. So it's not that, it's minus pi over 2,
Wait,
which I think could
what?
be kind of confusing.
How does it turn into a minus pi over 2 though? The
Well, if it's a coterminal angle. If you subtract 2 pi from that, um,
why do you end up subtracting 2 pi from that?
okay, so the sine inverse is only good from minus pi over 2 to pi over 2. And the angle we just found is 3 pi over 2. Okay. But that's not, it's like me telling you I need a number from 0 to 1 and you give me minus 1/2. Well, I have to do something to it to get in here. Like there's two ways to get to this point. You can go minus pi over 2, or you can go 3 pi over 2. If that's not clear, we can go keep going through that.
I could go through that a little bit more.
Okay, so I'm gonna go to my unit circle. So here's an angle, 30 degrees. Or I can go minus 330 to get there, which is
Oh,
correct.
okay.
Well,
Yeah.
they both are. They're both correct.
Hmm.
I'm another angle. I'm an angle over here at 150 degrees. Or I went minus 210 to get there, which is
Yeah.
correct. Well, they both are. That's what we're saying here. And that's what's confusing because like 3 pi over 2 seems correct, but it's only good from minus pi over 2.
Because of why?
It just, it's a definition. It's because the inverse function has to be 1 to 1. It has to pass the horizontal line test, and it's only 1 to 1 on this interval.
Hmm.
That's
Okay.
why.
Let's try that out a little bit more because it's still a little bit confusing. What's the next problem?
So we got to pick problems that are helpful here. Some of the ones that we've done so far are not very helpful. Okay, so like let's do 9. 9 is the cosine inverse of square root 3 over 2. So on your unit circle, there are two places where the x value is the square root of 3 over 2. We need to get those two values. They are, and we're talking about the x value, pi over 6, comma, 11 pi over 6. At the cosine of each of those values, it's the square root of 3 over 2. So which one is it? Well, cosine is only good in this window, 0 to pi. So
Okay.
which one's the correct answer?
So it's only in the window. Got pi. So pi over 2. 3 pi over 2. So
You've
looks
got
like
to know where pi over 6 is. Pi over 6 is right there, and
yeah,
11 pi
you're
over
right.
6 is right there. So it has to be that one.
This would be the one. Okay. One left. Okay.
All right, let's do another one.
Mm-hmm.
Okay, so the next one here that I want to do with you because it makes the most sense is 14 again.
Okay.
And it's because it's, so some of these, like they only have one value and then you're not choosing, but okay, so again, go to your unit circle. Where is
Red pi over 2.
x value root 2 over 2?
There's pi over 4, and then there's what is it? 3 pi over 4. Right?
It has to be
Or 2.
positive.
Oh yeah. Cosine. You already have it up there, so 2 pi
Yeah,
over 4.
make sure you confirm that. So cosine inverse though is only good from 0 to pi.
Mm-hmm.
So which one is correct?
First one.
Yeah. Okay, so that's how you do it. And really the right way for us to have done this is to do all the cosines and then all the sines. And we'll keep doing that here. So we'll do the next one here. All right, so this one says, where is the cosine inverse? For what angle is the cosine of that angle minus square root 3 over 2? So you're looking for, on your unit circle, where is the x value minus square root 3?
So 7 pi over 6. And then, which one is it? 7 pi over 6. Oh, then it's 5 pi over 6. Okay.
Right, so which one is between 0 and pi?
The left one. Yep.
Yep. All right, let's look at another one here. I have too many of these open. Okay, there it is. So then that's all oh, there's one more. There's a cosine inverse of 1/2, and then we'll do some sine inverses.
Inverse of 1/2. Okay. Pi over 3 and 5 pi over 3. Which one fits it? It should be just pi over 3, right?
Yep. Okay, so let's do some sine inverses.
Okay.
So sine inverse of all right, so for what angle is the sine of that angle square root 3 over 2? Where's the y value square root of 3 over 2? So there's two places in the unit circle, pi over 3, comma, 2 pi over 3. So just verify that. But sine inverse is only good from minus pi over 2 to pi over 2.
Okay.
So which one of these falls in there? Well, this first one.
Yeah, the first one goes in
Okay,
there.
but we're gonna do this is where it gets a little bit more difficult. We're gonna do
You have to make one negative or something?
negative root 2 over 2.
Oh.
Where's sine inverse minus root 2 over 2? Go to your unit circle and look for that. There's two places again. It's 5 pi over 4, comma, 7 pi over 4.
5 pi over 4 and then 7 pi over 4. Okay. And
Now,
7 pi over 4 works.
well, no, it doesn't. And this is where it can be confusing because neither of these are here or in this. Well, because 5 pi over 4 is here, and 7 pi over 4 is here, but it's not from minus pi over 2 pi over 2. So there's
so it doesn't work? Okay.
Well, it does work, but what you have to recognize is that this is also minus pi over 4.
Is that like the negative 2 pi or something?
Yep, it's the negative coterminal of that, or it's you get to it here, or you go the other way and get to it there.
Okay.
And then that's your answer. So neither of these are correct, but this one is correct when you convert it.
Okay.
And that's what I think is really has been unclear. And I think we're about to clear it up for you. So let's do 23. It's another negative here. All right. So again, where on your unit circle is the y value negative 1/2?
All right, let's see. Negative 1/2. So over at 7 pi over 6, and then there's 11 pi over 6 on here. Okay.
So again, notice that neither of these work, okay?
But 11 pi over 6 is in there, but we got to convert it somehow.
You convert it by subtracting 2 pi or subtracting 12 pi over 6, which gives you minus
-1
pi over 6. Yeah.
Oh, yeah. Negative 1 pi over 6.
All right. Okay, so we're going to stop here. The rest of these are here, but there's also another way you can do this. You can use your calculator.
Yeah.
Use your calculator, and then you convert. If you do it in degrees, you can convert from degrees to radians. Like when you did this one, your calculator, if you put this in your calculator, you'll get minus 30 degrees, and you can multiply by pi over 180 if you need it in radians. It's a trick, a cheat, a shortcut, whatever you want to use. It's totally reasonable if you know.
Do you put it in a regular calculator or an online calculator?
No, regular, TI-83, whatever,
So you get that. So where did you get the 30 degrees from again?
If you put sine inverse of minus 1/2 in your calculator and your mode is in degrees, you will get minus 30.
Oh, okay. You get that. and then you multiply it by pi over 180 because that's how you
If
convert.
you need to convert it to radians, yes.
Awesome. That's an interesting. That's an interesting technique. I'll use that for sure.
For
Thank you very
sure. I have
much.
no problem with using it. I forgot to tell you earlier because I forget that you have to do this in class sometimes.
Mhm.
So, okay, that's
I
all we
appreciate
got
your
for tonight.
time.
Yep. See you next
Have a
time,
nice
Jack.
day.
Thanks for scheduling. Bye now.
Bye.